This is not supposed to exist. Not this pattern, not this behavior, and not all in one place. At the 2026 Tucson Gem Show, some of the most crowded tables weren't showing perfection. They were showing minerals that break formation rules, a structure that looks manufactured but formed naturally, a crystal that changes after it's already formed, and one specimen that appears to follow a design nature shouldn't be able to produce. None of them resolve on first look, and that's why people stop. Because when recognition fails, attention doesn't move on, it locks in. Starting with one formation that doesn't just look unusual, it looks like it was built. Ranked 10th, Bismuth Hopper Crystal. It doesn't look natural, not at first glance, not even after a second look. Sharp edges rise in perfect steps, layer upon layer, like a structure built with intention, not formed deep within the earth. At the 2026 Tucson Gem Show, this was one of the few specimens that made people slow down without realizing it. Not because it was rare, not because it was expensive, but because something about it didn't register correctly. The brain hesitated. Crystals are expected to grow outward, to follow patterns that feel organic, balanced, predictable. But this looked controlled. Metallic surfaces shifted between gold, violet, and electric blue, depending on the angle of light. Each edge too precise, each layer too deliberate. It didn't feel like something that formed. It felt like something that was assembled. And that subtle discomfort, that moment where recognition breaks, is what held attention longer than most high-value stones in the room. Because understanding didn't come immediately. And when something can't be explained in a single glance, people keep looking. What makes this more unusual is not just how it looks, but how it forms. Bismuth doesn't grow like most minerals. As it cools, the outer edges solidify first, forcing the structure inward, creating hollow, stepped formations, a geometry shaped by rapid change, not stability. What appears precise is actually the result of imbalance, a system cooling too quickly, edges forming faster than they can smooth out, layers stacking before the structure has time to correct itself. What looks intentional is the byproduct of something happening too fast to stabilize. And once that is understood, the structure becomes even harder to ignore, because it reveals something unexpected. Natural formation is not always gradual. Sometimes it's abrupt, incomplete, even chaotic. At Tucson 2026, pieces like this didn't need explanation to attract attention. They worked instantly, but they didn't resolve instantly. And that gap between seeing and understanding is where attention stays the longest. Because once something stops looking natural, it forces a second question. What else has been misunderstood about how minerals actually form? And deeper inside the show, there were specimens that didn't just challenge appearance. They challenged the idea that formation always finishes the way it's supposed to. Ranked 9th, gold quartz. Gold is supposed to separate. Under pressure, through heat, across fractures in rock, it moves until it gathers into something distinct, dense, recognizable, complete. That's the expectation. But inside certain specimens at the 2026 Tucson Gem Show, that process didn't finish. Threads of gold remain suspended in pale quartz, not forming veins strong enough to dominate, not dispersing enough to disappear. Caught between states. From a distance, it looks like stone, unremarkable. Then the light shifts, and thin, irregular flashes begin to appear, not as solid metal, but as fragments of something that never fully became what it was supposed to be. This isn't gold in its final form, it's gold mid-process, and that difference changes how it's perceived, because what's being observed here is not just material, but timing. Hydrothermal fluids once moved through microscopic fractures, carrying dissolved gold under precise conditions. Normally, as those conditions stabilize, gold separates cleanly, but in these cases, stability never fully arrived. Pressure shifted, temperature dropped unevenly, chemical balance changed too quickly, and instead of completing the process, the system paused, leaving gold embedded, scattered, suspended inside quartz. Not lost, not refined, just unfinished. That incomplete state is what draws attention, because it reveals something rarely visible, the moment where formation almost became something else. At Tucson, these pieces weren't treated as imperfect. They were handled differently, rotated slowly under light, examined from multiple angles. Not to confirm what they are, but to understand what they almost were. And that subtle shift in perception matters, because most minerals are valued for their final state: clarity, structure, completion. This one holds attention for the opposite reason. It shows a process interrupted, a system that didn't fully resolve, and in doing so, it exposes something deeper about natural formation. Not everything reaches its intended end. Some structures exist because conditions changed too soon, because stability didn't last long enough, because completion was never guaranteed. And once that becomes visible, the idea of a finished mineral begins to feel less certain, because deeper inside the show, there were specimens that didn't just stop halfway. They changed into something else entirely. Ranked 8th, hackmanite. Under ordinary lighting, nothing stands out. A soft, muted tone, surface calm, structure unremarkable at first glance. Placed among more vivid specimens, it almost disappears. That is how most people encounter it. And that is exactly how it holds attention, because what appears stable is not fixed. The shift does not announce itself. There is no visible transition in real time, only a change in conditions, a different light source, a controlled environment. And suddenly, the same specimen begins to behave differently. Color deepens, intensity rises. Subtle tones give way to something far more pronounced, not as a reflection, not as an illusion created by angle, but as a response. What is being observed is not just appearance, but reaction. Hackmanite belongs to a small group of minerals capable of tenebrescence, a reversible change in color triggered by exposure to ultraviolet light. Energy enters the crystal lattice, temporarily altering how it interacts with visible light. Then over time it returns, not instantly, not dramatically, but gradually, as if the material is resetting itself. This creates a strange condition. There is no single correct version of the stone. What is seen depends entirely on when it is observed. At Tucson 2026, this behavior wasn't explained first. It was demonstrated. Specimens moved between lighting conditions. Displays shifted from neutral to UV. And each time the reaction repeated, not perfectly, not identically, but consistently enough to raise a question. If a mineral can change its visible state, which version is real? That uncertainty is what holds attention, because most minerals are defined by stability, by consistency across environments. This one resists that definition. It doesn't present a fixed identity. It presents a range. And within that range, observation becomes part of the process. The viewer is no longer just looking. They are triggering the behavior. That subtle shift from passive observation to active interaction changes how the specimen is perceived. It becomes less like an object and more like a system responding to conditions. And once that idea takes hold, the boundary between appearance and behavior begins to blur. Because deeper inside the show, there were specimens that didn't just change under light. They revealed that what appears to exist may no longer be there at all. Ranked 7th, Goethite after pyrite. The shape suggests one thing: sharp cubic edges, clean, repeating geometry, a structure long associated with metallic symmetry and stability. Everything about the form points to pyrite, but the substance does not match the structure. The metallic luster is gone. The weight feels different. The surface carries a darker, more subdued tone, closer to something that formed under entirely different conditions. This is not pyrite. What remains is its architecture. At the 2026 Tucson Gem Show, specimens like this created a different kind of pause. Not immediate visual shock, not dramatic color or light, something quieter, a hesitation that came from recognition, followed by contradiction. Because the mind identifies the form first, then attempts to confirm it through material cues. And when those cues don't align, the result is a subtle collapse of certainty. What is being observed here is a pseudomorph, a mineral that has replaced another over time, while preserving the original external shape. In this case, pyrite formed first, stable, metallic, structured, then conditions shifted. Fluids moved through the crystal. Chemical composition changed. Iron sulfide gave way to iron oxide, slowly, gradually, until the original mineral was no longer present, but the structure remained. Not a replica, not a copy. A transformation that occurred from the inside out. Every edge, every plane, every angle, unchanged in appearance, but entirely different in substance. That duality is what holds attention, because it challenges a basic assumption. That form and identity are the same thing. Here they are not. The structure tells one story, the material tells another, and neither can be understood without the other. At Tucson, these specimens were not explained immediately. They were examined, turned under light, compared against expectation, not to confirm what they are, but to question what remains of what they used to be. Because in cases like this, the original mineral is gone, not hidden, not altered, replaced, and yet its presence is still visible. That contradiction, absence within a preserved form, creates a different kind of tension, not visual, not optical, conceptual, because it suggests something deeper about natural systems. That identity can change completely, without appearance giving it away. And once that idea becomes clear, the act of observing minerals shifts. What is visible can no longer be taken at face value. Because further into the show, there were specimens where the conflict wasn't hidden beneath the surface. It was happening all at once, in full view. Ranked 6th Labradorite. Across multiple booths, the same surface kept appearing. Not identical pieces, not identical cuts, but the same effect. A dark, almost unremarkable base, until movement reveals something else entirely. Flashes of blue, gold, electric green, not painted on the surface, not added through treatment, but emerging only when the angle is right. At the 2026 Tucson Gem Show, this was not confined to a single display. It repeated. Tables of raw slabs, polished faces catching controlled light, carved forms shaped to exaggerate the effect. Labradorite was not rare. It was not positioned as a centerpiece, and yet it became one of the most consistently visible materials across the show. That presence raised a different kind of question, not about formation, not about rarity, but about attention, because the effect it produces, labradorescence, is not constant. It appears, disappears, and reappears again, depending on how the stone is viewed. Layers within the crystal structure scatter light internally, creating color only under precise alignment. Most of the time, those colors are hidden, which means what is being presented is not the material itself, but a moment, a brief alignment between structure and observation. That behavior changes how the stone is used. At Tucson, positioning mattered, lighting was adjusted, angles were controlled, not to improve the material, but to reveal what was already there, waiting for the correct conditions. This is where the shift becomes clear. The focus is no longer on what the mineral is, it is on when it becomes visible. Collectors didn't respond to Labradorite because it was rare. They responded because it required interaction, a slight movement, a change in perspective, and suddenly something hidden becomes dominant. That interaction creates a different kind of engagement, not passive observation, participation. Because the viewer is not just looking at the stone, they are searching for the moment it reveals itself. And when that moment appears, brief, precise, and dependent on position, it feels less like viewing an object and more like discovering something. That dynamic explains its presence, not as a headline piece, not as a rare anomaly, but as a material that holds attention through behavior rather than status. And once that distinction becomes clear, the idea of what defines importance at a show like Tucson begins to shift. Because further inside, there were specimens where contrast wasn't revealed through movement. It existed all at once, locked into the same structure. Ranked 5th, rainbow hematite. Attention doesn't move on immediately. Even when the structure is simple, even when the form is familiar, there is a pause, Not because the specimen is complex, but because the surface refuses to behave the same way twice. At first, it appears metallic, dark, reflective. Then the color begins to shift. Bands of red, blue, and violet emerge across the surface. Not as fixed zones, but as responses to movement. A slight tilt changes everything. What was visible a moment ago disappears. What was hidden takes its place. At the 2026 Tucson Gem Show, pieces like this did not rely on rarity to draw attention. They relied on repetition. People returned to them, not once but multiple times, because the experience was never identical. Rainbow hematite creates that effect through microscopic surface structures, thin layers interacting with light in ways that produce interference colors. Not pigment, not inclusions. Structure. Light enters, reflects, interferes, and exits differently depending on angle and surface condition, which means the color is never truly on or off. It is conditional, and that condition changes constantly. This creates a loop. Look, adjust, look again. Not to confirm what is there, but to see what changes. That loop is what holds attention longer than expected, because it removes certainty. There is no single version of the surface to remember, only variations, and each variation feels slightly different, even when the object has not changed at all. At Tucson, this behavior shifted how the material was handled. Specimens were not simply displayed. They were rotated, tilted, repositioned. Not to improve them, but to reveal different states of the same surface. That subtle interaction created something unusual, a mineral that encourages continued observation without requiring explanation. No rarity needs to be established. No origin story needs to be understood. The engagement happens immediately, because the viewer becomes part of the effect. Without movement, the phenomenon is incomplete, and that dependence on interaction changes the relationship entirely. The object is no longer static. It responds, not actively, but conditionally, and that is enough to hold attention, because it creates a question that does not resolve. Is the color part of the mineral or part of the act of observing it? That uncertainty is what keeps the gaze returning. And deeper into the show, there were specimens where contrast wasn't dependent on movement. It was built directly into the structure itself. Ranked fourth, Azurite malachite. Two colors occupy the same space, deep blue and saturated green, not blended, not fading into one another, but meeting along sharp, irregular boundaries. Each zone holds its own identity. Each resists merging. At the 2026 Tucson Gem Show, these specimens were easy to notice from a distance. Not because of size, not because of rarity, because the contrast felt unresolved. Blue pushes against green, green interrupts blue. Neither dominates completely. That visual tension reflects something more fundamental. Azurite and malachite originate from the same element, copper, yet they stabilize under different chemical conditions. One favors environments with lower water activity and specific carbonate availability. The other forms when those conditions shift. They are not meant to occupy the same phase at the same time, and yet here they are, not layered neatly, not separated cleanly, intergrown. What is being observed is not a simple transition from one mineral to another. It is a record of changing conditions, captured before the system fully resolved. As fluids moved through the host rock, chemical balance did not settle into a single stable state. Instead, it oscillated, back and forth, blue, then green, then blue again. Each phase forming as conditions briefly favored it, before shifting once more. The result is not harmony, it is interruption, edges that stop abruptly, zones that begin without warning, a structure that documents instability rather than completion. At Tucson, these pieces were not treated as decorative contrasts. They were examined for what they reveal, because they show something that is usually hidden. The moment when environmental conditions fail to stabilize long enough for a single mineral to dominate. That failure is what creates the pattern, not design, not intention, conflict. Two systems competing for the same space, each forming only as long as the conditions allow, then yielding, then returning. That cycle leaves behind a structure that feels unresolved. Because it is. There is no final state captured here, only a sequence of temporary ones, preserved side by side. And that changes how the specimen is interpreted. It is no longer just a mineral, it is a timeline, a record of fluctuation locked into solid form. Once that perspective takes hold, the contrast stops being visual and becomes contextual. Because further inside the show, there were specimens where instability didn't just create contrast, it limited how long the material could even remain the same. Ranked third, Benitoite. Visibility is not constant, not because the specimen lacks intensity, but because its most defining feature depends on conditions that are not always present. Under standard lighting, the structure appears precise but restrained. Edges are clean, color is present but contained. Nothing suggests what happens next. Only when the environment changes does the material reveal its full behavior. Exposure to ultraviolet light produces an immediate response. A concentrated blue emission that does not reflect surface color, but originates from within the crystal structure itself. The effect is not gradual, it appears all at once. And just as importantly, it disappears when those conditions are removed. At the 2026 Tucson Gem Show, this behavior was not left to chance. It was controlled. Displays were constructed to manage when the effect could be seen. Lighting shifted deliberately. Timing was intentional, because the impact depends on contrast between what is visible and what is not. Benitoite does not present its defining characteristic continuously. It requires activation. That requirement changes how it is experienced. Observation becomes conditional. Without the correct environment, the material appears incomplete. With it, a different state emerges, one that cannot be inferred from the initial view. This creates a layered perception. The specimen has a visible form and a hidden behavior, and the two are not experienced at the same time. That separation introduces a different kind of tension, because it raises a question that does not resolve immediately. Which version defines the mineral? The one that is always visible, or the one that appears only under specific conditions? At Tucson, this question was not answered directly. Instead, it was demonstrated repeatedly. Light on, light off. Each transition resetting the viewer's understanding of what they were observing, not through explanation, but through controlled exposure. That method of presentation matters, because it shifts attention away from static properties and toward behavior over time. The mineral is no longer defined by a single state. It is defined by a range, only part of which is visible at any given moment. That incomplete visibility is what holds attention. Not because something is hidden permanently, but because it is revealed selectively. And once that pattern becomes clear, the act of observing changes. It is no longer about identifying what is present. It is about recognizing when it becomes visible. Because further inside the show, there were specimens where even that visibility could not be relied on, where the material itself refused to remain the same for long. Ranked second, Tucson. What is seen now is not permanent. The color appears settled, soft, consistent, fully present across the surface. Nothing suggests instability. Nothing signals change. And yet that appearance is temporary. Not because the specimen is fragile in structure, but because its visible state depends on a condition that does not last. Tucson belongs to a rare group of minerals capable of reversible color change. Not instant, not dramatic in motion, but gradual, persistent, and dependent on exposure. Light alters it, not in a reflective sense, but at the level of its internal structure. Ultraviolet radiation introduces energy into the crystal lattice, rearranging how it absorbs and transmits visible wavelengths. The result is a shift in color, often deepening toward richer pink or red tones. But unlike a fixed transformation, this state does not hold. Remove the stimulus, and the process reverses. Slowly, not in seconds, not in a way that can be fully observed in real time, but across minutes, sometimes longer. At the 2026 Tucson Gem Show, this behavior changed how the material was presented. Not displayed as a single, stable object, but as something that required context. Timing mattered. when the specimen had last been exposed, how long it had rested, what state it was currently returning from. Each factor influenced what was visible. That variability created a subtle tension, because the viewer was not just observing a mineral, they were encountering it at a specific moment in its cycle, and that moment could not be repeated exactly. What is seen now may not be seen again in the same way. That realization alters perception. The specimen is no longer defined by a fixed identity. It exists across states, each dependent on prior conditions, and none of them permanent. This introduces a different kind of uncertainty, not about what the mineral is, but about which version of it is being observed, because there is no single reference point, only phases. A state after exposure, a state during recovery, a state before change begins again, all valid, all temporary. At Tucson, this instability did not reduce its appeal. It intensified it, because it revealed something rarely acknowledged in mineral formation and behavior, that not all materials remain consistent once formed. Some continue to respond, to shift, to move between states, even after crystallization is complete. And once that becomes visible, the assumption of permanence begins to weaken. Because if a mineral can change after formation, then the idea of a final, stable condition becomes less certain. And deeper inside the show, there were specimens where that uncertainty reached its limit, where structure itself seemed to follow a pattern that did not belong to natural formation at all. In first place, Trapeze emerald. A pattern appears before the material is understood. 6 dark arms extend outward from a central point, dividing the crystal into precise repeating segments. Not suggested, not approximate, defined. Each boundary holds its line. Each segment remains separate. At the 2026 Tucson Gem Show, this was not approached as a typical gemstone. It was approached as a structure that required explanation, because nothing about it aligns with how crystals are expected to form. Growth in minerals is usually continuous, gradual, layered without interruption. But here growth seems interrupted, not once but repeatedly, and with a level of consistency that feels deliberate. The emerald forms, but not as a single uninterrupted mass. Instead, inclusions, often carbon-rich material, establish fixed radial boundaries early in the process. As the crystal continues to grow, these boundaries persist. They do not dissolve. They do not blend. They divide. What results is not a variation in color, but a segmentation of structure itself. Each section develops independently, guided by the same external conditions, yet separated by internal constraints. That separation remains visible, not as a surface effect, not as an optical illusion, but as a structural truth. At first glance, the pattern suggests design. Symmetry is too precise, repetition too consistent. It resembles something constructed, not something that emerged through geological processes. That resemblance creates immediate tension, because it challenges a fundamental assumption that natural systems do not produce ordered patterns without gradual transition. Here, transition is absent. Boundaries are abrupt. Growth does not smooth them out. It respects them. And that behavior is difficult to reconcile, because it suggests that formation can be constrained in ways that override the expectation of continuity. At Tucson, these specimens were not explained quickly. They were observed, held under light, turned slowly, not to appreciate color or clarity, but to confirm that the pattern was not superficial, that it extended through the structure itself. Once that becomes clear, the question changes. It is no longer about what the mineral is. It becomes about how such a pattern could persist through an entire growth process without breaking down. That persistence is what elevates the specimen beyond anomaly. It represents a system where multiple conditions, chemical, structural, and environmental, remained aligned long enough to produce something that appears intentional. And once that idea is considered, the boundary between natural formation and perceived design begins to blur. Because what is visible here does not resemble randomness. It resembles control. And that is what makes it difficult to ignore. Because if a structure like this can form naturally, then the definition of what natural looks like may not be as stable as it seems. None of these minerals hold attention because they're perfect. They hold attention because they don't resolve immediately. A structure that looks manufactured, a crystal that changes after it forms, a pattern that shouldn't survive natural growth. Each one interrupts expectation in a different way. And once that interruption happens, it becomes difficult to look at any mineral as something completely understood, because what's visible is only part of the process. The rest depends on conditions that aren't always obvious. So the real question isn't which one is the rarest. It's this: which one felt the least natural? The one that changed? The one that didn't finish forming? Or the one that looked designed instead of formed? That answer usually says more about perception than the mineral itself.